So I've split this video into two parts. This will walk through kind of materials needed and how to mix those materials. The other video actually shows my setup and talks through when I'm mixing chemicals and stuff like that. So definitely look for the part two of this video. Okay, so today we're going to do the gold zinc plating, like a lot of the Honda bolts are done from the factory. I've got a lot of video of my setup and how to do it, probably instructions when I was setting everything up, but thought I'd do a quick recap for anybody that's trying to do it themselves. One warning is always wear gloves, eye, skin protection, work in properly ventilated area, and wear a respirator. You may or may not see me doing those things in the videos, but you should always do that because you are dealing with chemicals and acid that will burn your skin and potentially produce some fumes, etc. So the first thing is just kind of general items list. You'll need several plastic buckets. You'll see in the video, I started with I think it was maybe 2 gallon buckets, and I actually went to 5 gallon buckets to do larger items later on. Then you'll need a copper pipe. I just got this off of Amazon or somewhere. This is going to effectively go across the top of your bucket attached to your electrical lead. This is a form of electroplating, so you're going to need an electrical source of some sort. And then it has the copper wire, which is the next item that connects that copper pipe to your items. You can electroplate multiple items at a time. So, in some cases, you'll see where I have maybe 2 or 3 things in the bucket at one time. You'll also need 2 zinc anodes. I bought ones for actually evaporative coolers. They're pretty easy to find. I didn't buy the zinc plates. Some people buy zinc plates. I started with those. They really didn't work very well, and so I just went to the zinc anodes. And they had a wire that was epoxied onto them that I could quickly run. I ran 2, one on either side of the bucket. You can run 4 or 3 of them. It really, some people say, running more of them creates less shadowing, right, because of the electrical current. But in general, I found that I don't know that that's true. The solution has zinc in it, and it's going to plate. The electricity is going to kind of flow, more or less around the part pretty evenly. We'll talk about shadowing a bit later. You will need a DC power supply. I bought an adjustable unit off of Amazon that allows you to control how many milliamps. You'll use approximately 140 milliamps per square inch. So if you're doing like 1 bolt, you'll run a much lower current than if you're doing like a crank pulley or a big item like that. You need more core current to do the bigger items. And so it plates pretty well at about 140 milliamps per square inch. So having that adjustable unit helps. You can run some other power supplies. There are some cheaper options out there if you don't want to spend the $70 or whatever it is to buy the unit. But you're going to have kind of mixed results because of the fact that you're stuck at 1 voltage and amperage draw, so to speak. And then finally, a hair dryer. That's going to be the gold zinc, the actual gold chromating process. You're going to dry the part with that, and can kind of control some of the color tones and stuff depending on how much heat you put to it. So that's kind of general items that you'll need for this project. The other items specifically, you'll have an acid bath that you dip parts in before you plate them. You'll also rinse it obviously after the acid bath, but you'll have an acid bath. And so I use some acid for my pool. You add acid to pools if you don't have a pool. And so you just, dip the part in the muriatic acid. That removes any fingerprints and oils that may have gotten on the part since you cleaned it. It can also strip the old gold zinc off. In some cases, I'd screw up a part and you just dip it in the muriatic acid. It'll strip all the gold zinc off for you as well. So if you do screw up a part, you can practice with it and strip it in this acid bath. Then you have the zinc plating solution. So this is actually the electroplating solution that we'll do the zinc with. That's going to consist of Epsom salt. I believe it's about 8 ounces. You don't need a ton of it. This is not regular salt. It is nothing like table salt. It's a totally different chemical compound. Um, so you need some Epsom salt. Zinc sulfate, that's not actually required per se. It just helps if you put the zinc sulfate in your solution, then you don't have to worry about getting the zinc into the solution to start with. You're basically preloading it. Otherwise, if you don't put the zinc sulfate in there, then what you're going to have to do is you're going to have to put a scrap piece of metal in there, run the current really high to get the zinc off of the zinc rods and into the solution itself. I just bought the zinc sulfate, threw it in there, and that way it's ready to go. You don't have to worry about quote, I can't remember what they call it, but basically saturating the solution with the zinc from the rods. White vinegar, this is common in your kitchen most likely. And then there's optional, there's a brightener. This is glucose. If you had access to it, glucose would be the correct thing to buy. There are stores that sell these kits. Their brightener is just glucose. You can also use Karo syrup. I ditched this. I idiotically bought the darker Karo syrup, and so it didn't really matter whether it's the darker or the lighter stuff. I would buy the lighter stuff if I had to do it again. But the dark stuff, it has a little bit different, more glucose in it than the light stuff, and so I went with that. But honestly, I didn't like it. Didn't seem to do as well for me as just leaving it without the brightener. And then you'll need, for the gold and yellow chromate, you'll need battery acid. You can buy this generally at O'Reilly's. A lot of the other auto parts stores don't have it, but O'Reilly's generally carries it. You will not need very much of it, but it is very strong, right? And so be especially careful with the battery acid. The muriatic acid will also burn you if you get it on you, etc., at least in its non-diluted form. But well, even in the diluted form, it'll still burn you. It strips everything off metal, so that tells you something. But the battery acid is really strong, so always add the acid. So put water in the bucket and then add the little bit of acid that you need. Then you'll need sodium dichromate. This is the gold or yellow coloring that is going to soak into the zinc. And then you'll need distilled water for this. So you'll use distilled water. Everything else I use tap water with. For this, I use distilled water. So that's kind of the parts list for anybody that's trying to shop. You can come back and quickly reference this. So then we'll get into the mixing of the zinc electroplating solution. So for every gallon of tap water, we're going to add 8 ounces of Epsom salt. Again, if you do 4 gallons, then you need 32 ounces or 2 pounds of it. You'll need 3 ounces of the zinc sulfate. Again, I think I used closer to a pound in my 4-gallon bucket, but you don't have to mix it that strong. I just add a little extra, and then 5 to 6 ounces of white vinegar. And again, this is per gallon, so if you do multiple gallons, just multiply that out. Acid bath, same thing. For every gallon of tap water, you're going to add about 6 ounces of muriatic acid, and just one for one stir it up, and that will give you a good stripping. It'll strip stuff. You can mix it a little weaker if you want to be a little safer. I wouldn't necessarily recommend going stronger, because the ability to etch your metal or actually eat the metal that you're trying to plate is there. And so I would actually, go on the weaker side. I wouldn't try to make it stronger than this, because it will eat your metal, and before it eats the coating off, it'll have eaten or etched your metal. So that's not something that you want. And then finally, we have the gold chromate, which is 1 gallon of distilled water, the 35 mLs of battery acid. And again, avoid this stuff. Wear skin protection gloves. Make sure to wear eye protection, etc., because it is nasty stuff. If it gets on you, it's going to burn you. And then 12 ounces of sodium dichromate. Again, you'll buy this on eBay. There's a couple of stores. It's fairly expensive in my, finding whenever I bought it. And so that's how you're going to make the 3 buckets. You're going to have the electroplating solution, the acid bath, and then the gold chromate. I guess I should have done it in, because the acid is actually first, but so be it. And so you'll have 3 buckets there. And then you can have another bucket. I used one rinse bucket just to save space. You could run two rinse buckets. You could do one for after the acid bath and then one after the gold chromate or yellow chromate. That's up to you on whether you want one rinse bucket or two. You just need to rinse it, flush it more frequently, because obviously parts coming out of the acid bath are going to put some acid in that mix, and you don't want it too much. And same thing when you do the yellow chromate, it's going to turn that water yellow. And so if you use one, you're going to have to kind of replace it frequently. So now we'll get into the plating process. Obviously, clean and strip the part. Um, honestly, if you have access to it, a media blaster, sand blaster, blasting cabinet, whatever you want to call it, definitely does not hurt, right? I don't have one, so I ended up just stripping everything off, cleaning it with Simple Green, and getting it fairly clean and fresh down to the metal, so to speak, up front. I hooked the part. Again, you're going to have in the video, you can see a little bit later, you'll see where you have a copper pipe and then a copper wire that you hook the part to. And same thing, if you have old coatings and stuff, if you dip it in that acid bath, it's going to remove it. It will take potentially several minutes at times. But if you've already cleaned the part and stripped the part, etc., then you're just going to dip it in that acid bath for a few seconds to remove any oils from your skin, etc., off, and then dip it into the rinse bucket. Then you're going to move that directly from the rinse bucket. You're going to put that part and put the rod across your bucket, right? So it's going to be the rod across the bucket with the wire going down, and then your part suspended in your electroplate solution. You're going to hook up your leads from your electrical source to that, and then run the proper electrical current, again 140 milliamps per square inch of parts that you have in there. You can run multiple copper wires with multiple parts all at once. Sometimes I was doing that, sometimes it wasn't. So there's a few other caveats that you'll see. Some things do shadow, right? Electrical current wants to take the path of least resistance, and therefore, if you have a more complex part, it's going to tend, like on bolts, not that it matters that much, but like the threads, the inside parts of those threads aren't really going to get zinc coated very well. My power steering pulley, my crank pulley, all of those things, are difficult to get on the inside of that pulley, because it all, the zinc just wants to go to the outside part of the pulley. I personally use tape, and so I would zinc part of it and then tape off the parts that were plated really well, and the tape will prevent that electrical current from depositing more zinc in that area. Professional places that are doing production, lots of the same parts, they'll actually create plastic shields and do this in a multi-stage process as well. If you're doing flat washers, bolts, stuff like that, it's not really that difficult. The only thing I really had to do it on was the power steering and crank pulley. Everything else I was able to do pretty much just dip it in, hook the electrical up, and then run it. So that's pretty good. So when this comes out of the zinc plating, it is going to be a dull gray, chalky finish. You're going to want to let that dry all the way, let it sit for a few days potentially. I didn't always let it sit like I should, but you probably should let it sit to take full effect, but you definitely want it dry. Then you can take a copper brush and you're going to brush that part, and it's going to turn shiny. Some of the OEM Honda parts are that dull zinc finish, right? I'm sure that you've seen a few of them. They're dull zinc, just plain zinc, not polished and not gold chromated, just dull zinc gray finish. If that's the part, if that's the look that you need, then just leave it right as it is. If you need it gold, then you're going to need to polish it again. Use the copper brush, polish it. You can technically do a final polish with a steel wool as well. I put a normal polishing compound on it. I did not have good results with that. I've seen other people online that have good results with that. I think maybe part of that was I didn't allow it enough time to properly set up. And I was trying to do it, too quickly, probably, 20 or 30 minutes after I removed it from the zinc coating process. I was trying to polish it, but seemed to work pretty well for me. And again, you can figure that out. You do some test pieces, etc. So once you've got that polished to like a mirror shine, then you're going to dip it into the gold/yellow chromate. So depending down here, I've actually talked about how you can do the factory Honda. So some of the new factory Honda bolts that you'll buy aren't gold chromated; they're silver chromated. You can dip those in the gold chromate solution. You don't have to re-zinc it; it's already zinc. You can just dip it in the gold chromate. Those parts are going to be different than the parts that you zinc coat yourself. Now, part of that is the fact that they are, I believe, using a chromating process. I believe that they use a silver chromate. I don't think it's just a zinc. I think it's actually silver chromated. And so I think they're still running a chromate, but you can get it to a nice yellow color if you dip it in. But your time's going to vary. Same thing. Some of my parts varied on the amount of time that I need to dip them in for. I'm not really sure if that's due to the thickness of the zinc or what, but I checked it pretty constantly. I would pull it out after, I'd swirl it around. I wouldn't just dip it in. I would kind of move it around the chromate a little bit, pull it out. You can generally tell pretty quick whether it's, oh, hey, it's already too dark, or hey, it's a little too light. And so the other thing is that once you pull that out, you can kind of let it air dry before you rinse it. Right. And so if you chromate it for 15 seconds, you pull it out, it's a little light. If you just let it sit there before you rinse it, it'll absorb a little bit more of that chromate, get a little bit darker, and then you can rinse it. And then you'll remove any chromate that's remaining that would absorb in, etc. And then you're going to apply that hair dryer. You don't have to do this step, but what I found is that by applying the airflow and potentially heat, you can get some different iridescent colors. If you've seen, I think I've got some reviews of the different Honda colors. Actually, maybe later in this video. And even from the factory, this stuff varied in color thickness. The different providers or manufacturers had, it could be a little light, it could be a little dark, it could have a green hue to it, it could have a purple hue to it. And so you can kind of control that color, the iridescent color, that when you look at it, if it's got a purple hue to it or a greenish hue to it, etc., by how much airflow, the heat control on your hair dryer. So that's the whole process. I've got, I don't know, 20 or 30 minutes probably going through this as well, but thought I'd do a quick list that if you're trying to do it, you can quickly reference. Again, plate roughly 140 milliamps per square inch. That's your electrical. You can plate the new Honda parts. Not everybody's a Honda fan, but if you do own a Honda and you bought new Honda parts, they, were gold in the 90s. Now they're silver. You can plate those. And then obviously polishing your zinc parts, you really want to get that to a mirror finish for it to look the best. So a couple of pictures. I've got a whole video that goes through me setting up this process, etc. But did want to include some quick pictures here. This first picture is of just the after the zinc process before it gets polished. It's a dull gray directly out of the zinc. Then you get into where it's been polished and it becomes shiny with the zinc on it. And then finally here we've got the gold chromate. And so that's after you dip it in the gold chromate solution. A couple other examples here for good measure. These bolt here, you can see the zinc was run too quickly on it. You can see there's not very good dispersion on that top bolt. There's still rust and stuff on it. Wasn't prepped very well. And then it was run too fast and probably for too long for that matter as well. The good news is you can always strip those bolts and simply refinish them. Now we'll get into a couple other examples. This was the power steering pulley after I think I prepped it. So I'd stripped it. It was rusted. You can see where the rust was versus original zinc. This is after I zinced it. They're shadowing. So on parts like this, the zinc won't get in the crevices. So like in this particular case, behind the where the belt goes, basically on that back side, it doesn't want to get on that flat spot on the inside part of the pulley. And so I ended up taping it off. You can see some tape residue there. It did leave a little bit, some thicker parts where the zinc went on a little thicker with and without the tape and stuff. But overall, I did get good coverage on it. And you can see where it's been polished here. And finally, here's the final product. Nice and shiny, nice gold finish on it. Turned out pretty exceptional, in my opinion. Wasn't terrible at all. So I also did a bunch of other parts. You can see my original rusted fuel hose. That's Type R specific, so I had to refinish the factory one versus using one off of the GSR. There's pictures of it, I think, in the extended video where I go into the actual zinc process. Or yeah, the actual zinc process. I think I got some pictures on the car. If not, I'm sure they're out there. Power steering hose also got refinished completely. A little dark, but it overall, I think it'll actually lighten up with time, so I think that's fine. I also did the tube on the back of the motor. It's a little bit different. I don't know why the other ones that I had, even with the correct number of nozzles on the back, had pins versus little tabs on them. So I refinished that as well. Didn't get all the pitting. It was pitted, and when the metal's actually pitted, it won't obviously be perfectly smooth, and so it didn't come out perfect. But on the back side of the motor, it came out pretty well. And I wish I had before pictures. I think there's before pictures on my Instagram page. Yeah, my Instagram is ITR_98_0111. And you can see some before pictures of the throttle body there, but you can see that it came out exceptionally well. It was rusted, so the fact that it came out this clean is really nice. So hope you enjoyed the tutorial. There is another video that follows up that goes through my actual setup and walks through that. So check that out as well.
Hey guys, hope you enjoy watching the restoration of the rusty Barnacle, Integra Type R 98111. Please subscribe and keep looking for updates. Thanks.